often question one on AEA papers is relatively gentle compared to the rest of the questions. However, I think this is the hardest question one in an AEA paper. At the time of writing anyway, that this is definitely the one that springs to mind. Because it's very easy to get bogged down essentially in this question. It might be tempting to do addition formulae rather, on tan and cot and get an equation in terms of tan theta. It's going to be tan 35 and tan 53 in there. Now you don't want to do that. It's just going to lead to lots of pages of simplifying and so on, and quite possibly to a dead end. So I'm going to show you two ways that are much better. I'm going to show you quite possibly the way that you'd think to do it first of all, and then like a really quick way. So how you might think to do it is not to deal with tan and cot, but instead to deal with sine theta plus 35 over cos theta plus 35 and set it equal to, it's going to be cos theta minus 53 over sine theta minus 53. Now, if we cross multiply, we'll get sine theta plus 35 times sine theta minus 53 equals cos theta plus 35 times cos theta minus 53. Now, this might not seem particularly nice either, but there is something going on here. Essentially, we have sine A sine B equals cos A cos B. So if we can rearrange that to cos A cos B minus sine A sine B equals 0, then we can recognize that this is actually the addition formula for cos A plus B. And that's how we can crack this problem. So I'm going to just write it in full. It's going to be cos theta plus 35 times cos theta minus 53 minus sine theta plus 35 times sine theta minus 53 equaling 0. And using the below, therefore, cos of theta plus 35 plus theta minus 53, that's my A and that's my B, is equal to 0. Therefore, cos of 2 theta minus 18 equals 0. And we can take inverse cos of 0, no problem. So 2 theta minus 18 will equal 90. That's going to be one possibility. Just got to think, what is the range of values? It's between 0 and 180. And you can, by the way, you can therefore say that it's going to be 2 theta is going to be between 360, and therefore 2 theta minus 18 is going to be between 342, and this is going to be minus 18 here. So this is the range of values that we're interested in. And so I've got 90, or it's going to be it's equal to this one. It's equal to 0. So the next one's going to be 270. And then we're going to go beyond the range after that. So therefore, 2 theta is going to equal 108 or 288, and theta will equal 54 degrees or 144 degrees. Okay, like I said, not easy at all, but that's one way of getting the answer. Right, don't leave this video quite yet because I want to show you a second method, and it is well worth seeing. So we're going to return to tan theta plus 35 equals cot theta minus 53. Now there's actually an identity that cot of x is in fact tan of 90 minus x. This can be seen if you apply transformations to tan. I'm not going to go in that right here because that's not a convincing argument. I would like to show you a more convincing argument, however. And if we draw the unit circle and then a triangle within it. Now we normally use x and y here, so I'm going to use theta, and I'm going to prove that cot theta is tan 90 minus theta. So from this unit circle, I can see that cot theta is going to be the adjacent over the opposite is going to be x over y. Meanwhile, this angle here, because that's 90, this angle will be 90 minus theta. And therefore tan 90 minus theta will be the opposite over the adjacent, which is also x over y. And we can extend for all angles as you draw different triangles in there. They're obtuse or reflex angles, and it will still essentially apply. And therefore, we have this identity. It's really nice. So we're going to use that. And therefore, I'm going to get it all in terms of tan, because tan's a little bit easier to deal with. Tan of theta plus 35 will equal, right, and now we've got cot x. So this is going to, our x is this bit here. So it's going to be tan 90 minus theta minus 53, which is then going to be tan 143 minus theta. And therefore, theta plus 35 will equal 143 minus theta. It must do if these two tans are equal. There could be other solutions as well, but I'm just going to get this one to start with. So I'm going to get that 2 theta is equal to 178. No, sorry, I should have subtracted. What am I doing? I've added theta to both sides, and then I need to do 143 minus 35, apologies, so that should be 108, from which we get theta is 54 as before. Or theta plus 35 will equal 143 minus theta plus 180, because tan is periodic in 180. And I could also add 180 onto that side. I'm just going to, this one will get me my second solution. And you can see that theta is going to be larger because I'm going to get the theta over again. 2 theta. I'm going to minus the 35, which will give me 108. And then I'm still adding the 180. So you can see that this value of theta is going to be bigger. So divide everything through by 2. Theta is equal to 54 plus 90. I've avoided having to add these and then divide by 2. I'm going to get 144. So this is a really solid method, super quick. Gotta say, that's a great method, but it uses this little fact here.